So how to visualize multiple linear regression model? In case of simple linear regression, it's easy. You have one x, you have one y, right? And then you will have a line and then points somewhere. But if you have multiple linear regression model, it's more tricky because you have at least two x variables, right? So you have x1, you have x2, you have y. And if you have more than two x variables, then it's even more complicated because you cannot make like 4 or 5-dimensional plots. So let's concentrate on this example if you have two predictors. Well, as I said also at the very beginning, that the model is a hyperplane, right? So what it means? It means that you have x variables here, you have y variable here, and then for every combination of x1 and x2, you have one single point on this plane. And this is the predicted y value, right? Likewise, you have predicted y value, you have the real y value, and then the distance, the orthogonal distance between y and yp, Euclidean distance between these 2 points, it's the error of prediction. Okay. How to make this visualization? Well, there are several ways. First of all, you can download a special package, for example, in R, and make it indeed as a I'll show you, of course, in the R session case how to do it, and make it just a plane. So in this case, you can see I visualize model where income, this is income, depends on h and region. So this is just the model. However, the interpretability of this model depends also on the angle, how you look at this. And strictly speaking, for 3D plots, you need to rotate the plot until you get a good view, right? So there is a workaround. What you can do, you can just look at from the top, right? And that will make a plot which is called a counterplot. So what is a counterplot? The counterplot, it's a plot where you have only x. So this is x1, this is x2, right? And then you can see these are the contours. Yeah. And the meaning of these contours is that they all have the same salary. So the contour is kind of when you cut, you remember you also can have this counterplot for the mountains, for example, right? So to show the elevation, you simply cut this surface in 2 pieces. And every time you cut it, you have this contour of cutting, the cutting line, right? The cutting edge. And this cutting edge, you see it here. You see them here. Okay. So you can actually make a simple one like this. And then you can see that, for example, all these values is for 22,000 kroner. So it means that for any age, and for any region value, of course, in this case, it's kind of simplification because we cannot have region beside these 2 values. But let's imagine that region is quantitative just for the sake of simplicity. So if you have a region somewhere here, for example, right, and age here, this person who has this age and this region will have a salary, which you see here, right? It's 22,000 krona. Okay. How you can use it? For example, you can make a relationship. So how to get, for example, how to get all these points here, right? So in this case, income is 22,000, right? 22,000. So it means that 22,000 equal to minus 535.5 plus 812.3h minus 3613.4 region, right? So this is my model. But now income is known, so I can just add 535 to both cases. So I will have 22535.5 here equal to 812.3h minus 3613.4 region, right? Now what I'm going to do, I will put h also here, right? And then I will divide to 3613.4, and that gives me how region depends on age to get exactly income 22,000, right? So for any age, I can compute region value to get income exactly on this line, okay? So this equation, what you see here, it's equation of this line, income equal to 22,000. Then I can change income, for example, to 20,000, to 18,000, to 15,000, and get all equations of these lines here, and that will be my counterplot. Let me show you an example. So let me use this expression, and then, for example, let's say age is equal to 30 years, right? So I can compute a region based on 30 years. It's 0.547. Again, it has no meaning in this case. Region has only -1 and +1, but imagine that region is also, for example, we are not talking about region, but about IQ or height of people, right? So we can do these computations. And now if I show the plot, this is 30 years old person. This is the region of 0.547. You can see the points is exactly on the line where I have 22,000, right? Moreover, I can actually generate, now I will use R. I can generate points for age between 20 and 40. So it's 20, 21, 22, 23, 24, and so on and so forth, 21 points. And then I can compute region for every point from age. So it's just R code. You can just repeat it if you want. And after that, I can show these computed values as points on the counterplot that I made before. And these are the points. You can see exactly line on this line where we have 22,000. So all these points, all this combination of age and region, they give the same income, which is 22,000 kroner. So this is what the meaning of the counterplot, and this is how counterplot is actually made. Okay. So I'll show you the all necessary R code, how to make all these plots, 3D plots and counterplots at the end, in the last video, how to do things in R. Meanwhile, let's talk about interactions.